Okay, let's go ahead and get started. I'm Charlie Smith, the Executive Director of eSig. I want to welcome you to our eSig monthly webinar for June and give you a little bit of background on eSig. For those of you not familiar with eSig, we're a membership-based nonprofit organization providing our members with objective information, resources, and networking opportunities in support of the energy transition. We do this through workshops, tutorials, webinars, blogs, working group and task force activities, and producing technical resource materials. I also serve in a leadership role with the Global Power System Transformation Consortium, the GPST, whose mission is to bring together key actors to catalyze a rapid, clean energy transition at unprecedented scope and speed. eSig leads Pillar 1 of the 5 pillars, which deals with the research agenda for the system operators. More information on the GPST can be found at globalpst.org. We recently finished up 2 special topic workshops in Denver, one on grid forming inverter applications and one on forecasting and markets. And as might be expected, it felt really good to be back in person again. We're now beginning preparations for our fall technical workshop, which will be held in Minneapolis during the week of October 24. This will be in person as well, and further information is available on our website. Our workshops and monthly webinars are open to everyone, so please feel free to register anytime on the eSig website. If you're new to eSig, I strongly encourage you to follow up with us if you like what you hear, and I think you'll be pleasantly surprised. eSig membership will give you an opportunity to participate actively in all of our working groups and task forces. You can find us on the web at esig.energy, as well as on LinkedIn, Facebook, Twitter, and YouTube. Okay, just a few logistical matters before we get started. First of all, phones will be muted for the duration of the webinar to avoid unnecessary distractions. For the Q&A, we're using the Slido platform, so to ask your questions, please go to slido.com and enter eSig23 as the event code. The instructions are also at the bottom of the screen. You'll see a thumbs up button next to the questions to allow you to cast a vote to help prioritize the questions submitted. We plan to save 10 or 15 minutes for Q&A at the end and then wrap it up at the top of the hour. An email with a link will be provided once the video file has been posted. We also plan to provide short responses to unanswered questions after the webinar, so please don't be afraid to ask your questions through Slido. So today's topic will be on the subject of power system engineering challenges for systems with a high share of inverter-based resources, or IBR. As the power system becomes increasingly complex with the addition of IBR, so do the interactions among the many different players involved. And here to talk with us about it today is Andrew Isaacs, Vice President of Electranix in Winnipeg, Canada, where he's been for the last 20 years. You may remember Andrew from a webinar he gave about a year ago with some very creative hand-drawn sketches. He has played a key role in the advancements of electromagnetic transient modeling, including special applications such as SSR and control system interactions. He's a very active contributor to NERC, CGRE, and IEEE working groups and eSig projects. We have 95 shared connections on LinkedIn, in spite of him being in the frozen Northland, where the average annual temperature is a little above freezing, but the internet access is excellent. I consider Andrew a good friend and a good friend of eSig, and it's a pleasure to have him back here with us today. Today's webinar will look at IBR system challenges through an engineering lens. There are many and varied engineering perspectives, covering the range from engineering and design to planning and operations. And this talk will focus on some of the challenges common to all of those in the power systems engineering community. It will highlight the need in the coming years to achieve an unprecedented level of cooperation among these diverse groups and achieve a common understanding if we're going to solve our common problems by suggesting some avenues to increase this collaboration. I greatly value Andrew's contributions to eSig and the industry, and I look forward to what he has to say. Just a short reminder once again to use Slido at slido.com with the event code of eSig23 to ask your questions. Okay, without any further ado, let's go ahead and get started. Andrew, I'll now turn it over to you.
Thank you, Charlie. Um, Thank you for the kind words also. I appreciate the opportunity to talk today. Like Charlie said, my name is Andrew, and I got a disclaimer or a couple of notes before I start this presentation. So those of you who came in looking to just right off the top, learn how to plan and operate a system in transition to IBR, probably going to be a little disappointed. I'm not going to really tell you exactly how to do that. Just a note about us, we're a Canadian consulting company. We do a lot of power systems modeling and simulation. I put some characteristic logos for where I live on the top of the slide here. Winnipeg Jets, Winnipeg Blue Bombers, University of Manitoba, and then you might know we have some kind of extreme temperatures sometimes. So Charlie asked me to do this presentation, gave me the title, and I said, Charlie, I don't know if I'm qualified to do that presentation. He says, just give it a shot, he says. So I'm used to talking about, these things that Charlie mentioned, grid forming converters or PSCAD studies or large system models or, control issues and this sort of stuff. So today is going to be a lot more hand waving, high level ideas. My qualifications for this are I have many customers. I have developers as my customers, generator owners, OEMs, TOs, ISOs. Some of them are on the phone today listening, research entities, other consultants. And I talk on the phone with them a lot. So that's one qualification. So qualification number one, I talk on the phone a lot. Qualification number two, I listen to the news sometimes and read it. So you might say, well, Andrew, those are also my qualifications. So that's fair. And you could say I'm a little out of my wheelhouse here. So I'm gonna do this presentation. Take what you like out of it. Forgive me for being out of my wheelhouse, and I'll also warn you that there are some probably unfair caricatures to follow. Okay. So let's start with an unfair caricature. Switch the slide here. There we go. So if we take just a thought exercise to look at renewable energy and the renewable energy transition through different eyes, right? The different lenses. If we start with my teenage daughter, for example, or your neighbor, or an environmental activist, or a school teacher, or someone, you might get these kind of ideas that climate change is happening. I can see it. Fossil fuel is the problem. Renewables are the solution. You might have heard the phrase "blah blah blah," right? It's a famous one. We're moving too slow. We need to turn off those dirty fossil fuels. Now, this is an important perspective, um, and a valid one, and it's something that we all encounter pretty much all the time. So let's try a different perspective. If we look at the perspective of somebody who's in a political role or in a commercial role, I sort of equate those, are not quite fair to do that, but on the left side we just see money, right? I mean, you see a 3-year trace of a renewable energy index here. People get used to looking at these lines and they matter a lot, and we try and figure out what the line is going to look like in the next little while, and that drives how we're going to view renewable energy, whether that's from our own personal enterprises or from another one. And then there's the political lens, which I realize now that I've got an elections Manitoba ballot box on top of a picture of Boris Johnson in front of a wind farm, which sort of looks like Boris Johnson's looking for office in Manitoba. I don't think he is, but I'm sure you've all seen a picture of a politician in front of a renewable device in some sense, and what they're trying to do is, you know, um, somehow benefit from that politically. So another perspective. Let's try another one, and maybe a little more sophisticated one. Um, if we look at what renewable energy looks like from now a renewable energy policy thinker, or maybe even a climate scientist, and they would be probably horrified to find a screenshot from a Wikipedia page on here that I found. But let's just call it a caricature and say that you've probably seen this before, where we hear that 100% renewable is economic, feasible, the barriers that we see in front of us are really social ones, not necessarily technical ones. Um, Generally, they will equate different types of renewable energy. So hydro and solar and wind, it's all renewable. It's all good. Um, you get some debate about whether nuclear is good or whether biofuels or whatever. But generally, we don't. There's a very simple understanding of how those things work. And then the problems that they see are climate change denial, fossil fuels, lobbies, um, that old dusty power system infrastructure. Um, we are all using too much energy and so on. All of these things, again, very valid and important perspectives, and generally pretty well communicated probably to the rest of the world. So they have a Wikipedia page, right? By the way, it's an interesting page to read as a power systems engineer. And then at the bottom of the list, there's some financial constraints that we're worried about. So those of you who are energy thinkers on the line, apologies for the unfair caricature. Um, Definitely, this is a layer of sophistication beyond the others, and generally productive and useful, but still not really the way that power systems engineers tend to see the world. So how do we see the world? When you talk about the renewable energy transition, the first thing that came to my mind just as a reaction is, uh-oh, like this is a big thing. Then lots of other problems come to mind, right? We have inertia, we have protection problems, we have spinning reserve, reliability. We're worried about ramp rates and duct curves and cost. The idea of the whole thing being technically feasible doesn't really bother us. We believe that it's technically feasible, but we're also overwhelmed with, practical problems like I've got 3 people in my study department, and I don't know how to tell you if it's technically feasible for sure. I don't really know if it will work. I don't know if it's safe. Um, we need to do a study. I'd like you to show it to me, so that I can see it. And we use a lot more, tools that are essentially incomprehensible to the rest of the world, like simulation tools. And what we're trying to avoid is these, secret transformer fires and lights going off. So zooming in a little on the power systems engineering perspective, it's okay. Our lens is generally invisible and irrelevant to the outside world, right? Unless it really gets in the way of a political initiative. Somebody says to a politician, no, it can't be done in the time you're saying, then there's a problem, and you'll get noticed. Um, I find it amusing that if you're at a dinner table and the lights go off for some reason, it's really hot or cold outside and the lights go off, and where do the heads at the dinner table turn towards, right? Then all of a sudden it's, well, what does the power systems engineer think? And if it's a big enough problem, then the heads are rolling again. But generally, we don't mind being, invisible because we're busy. We got lots of our own problems. We have, within our communities, we have lots of perspectives and lenses, and we're having enough trouble often seeing the world through those lenses outside of our own sort of silos. So I put a couple of versus statements here. So we've got operators versus planners. Um, Again, a caricature. We have region versus region, competing interests, researchers versus other researchers trying to, competing with each other, transmission owners versus generator owners, transmission versus distribution is another nice demarcation line. And then lots of subcultures mixing in too. We have consultants like us who are, feels like we're trying to make everybody happy at the same time, but also, competing with other consultants. We have protection groups who are talking about sequence components. I don't know. You have research labs who are, they're working on their projects and competing for DOE funding. We have OEMs in the mix who are, their own whole world. Universities, EPC contractors, software vendors. All of these people kind of speak the same language. definitely outside those other lenses that we talked about, but we're kind of in our own world. So I wanted to take a moment to just note some issues that we have in common within our power systems world that are really important, but kind of invisible to the rest of the world. So one of the big ones, right? One of the most important ones is that we know that conventional IBRs or wind turbine, solar, battery, all of these things in isolation, don't work, right? They don't work. And that's something that isn't, I don't think, well understood. Maybe it's our fault for not communicating it. We also suspect, and in some cases we know, that if you just turn off all of the conventional stuff and turn on uh, or turn off all of the fossil fuels and turn on conventional IBRs, they don't work, at least not the way we think or the way we expect. And this is seen first, usually first by the planning studies that are done by the planners. But now all of the groups that I've mentioned deal with this either as a problem to be solved or as an opportunity maybe to to get work done. But operations are seeing this as well, and this is a sort of a fundamental um, issue that is a bit invisible to the rest, but we're all dealing with it. Likewise, increasing system complexity, right? We've got the combinations and permutations of generation. So now we're considering DER alongside of sometimes bulk grid. We're considering batteries that could be charging or discharging. A lot of the generators are small, so there's many of them. Load distribution is changing. And so the amount of things that need to be studied is bigger. We have more to do. At the same time, we can't easily predict how those generators or load resources are going to be behaving alone or together because they're new and complicated. So we need more accurate models and simulations. So in the planning groups, they're looking at new tools to try and understand how to do that. That would be like EMT tools, maybe not new, but new applications of them. The conventional modeling approaches are being shown, for one reason or another, to not be able to predict correctly some of the reliability impacts that we're seeing. Again, in the planning groups, this is easy to see, but what's happening now in the operations groups, for example, is that this is now impacting them in that they're not sure whether they can trust that the modeling that they're doing from day to day is going to get them where they need to be. And likewise with the distribution folks. Other issues, we have an increased demand for expert human resources, right? I'm sure that I see 250 people on the call. This is something that is important to you in some way, right? Whether you're one of the experts that's moving around or having some experts leaving your group or joining, there's a perpetual squeeze on our technical staff. This is something that is happening right now, especially in the last couple of years. And experts moving around isn't the same as a net zero expertise, right? If you have an expert leave your group, that leaves a big hole that you can't immediately fill. And that expert doesn't, when they go to the next group, it doesn't fill some other gap immediately. I shouldn't say it. They don't fill that gap. There's a net decline in sort of overall productivity when that happens. I'm not saying this is people shouldn't be moving. I'm just saying this is a fact that there's a squeeze right now on technical capability within all of these groups. We've got increased speed of interconnection, so the pressure's on from your teenager, right, and the politicians. It's coming faster than anybody guessed, and it's still not fast enough. We also have an increased speed of a technology shift. So what I mean by that is that these devices coming in, IBRs, are high-tech devices. They're essentially products of very short R&D cycles. They're working very fast to improve them all the time. And so we have, products that are coming to market. By the time they've been the study has been finished. They've already, moved on to the next product, and so the ability to keep up with these cycles is very hard for everyone. And of course, we have this increased regulatory pressure to speed up. So, all of this is to say that all of our groups within the power systems community are having a little trouble keeping up, right? I wanted to give a couple of example problems, just kind of for fun almost. And I really like this first one. So an example of a real world issue, or maybe we'll call it a communication breakdown. So we have a transmission planning study that's looking at point-on-wave breakers. And the study looks at a trade-off between closing the breaker when you energize a circuit on a voltage peak or on a voltage zero. Okay, so voltage peak, if you can hit it on the voltage peak, you might minimize the potential for a current zero miss, or making sure your current is pretty close to a zero crossing, and a voltage zero. So if you hit it on the voltage zero, then you're likely to mitigate to some extent transient voltages that end up on the circuit and maybe protect your arrestors. So they showed this trade-off, and a couple of weeks later, after the study was finished and sort of understood, a couple of 500 kV breakers exploded. Now, operators who were programming, or maybe who were sort of controlling this scenario, closed on a voltage zero and then immediately opened again, and had a zero miss on the breaker, and there was a huge debris field. So this is an example where if we had actually just had a conversation about that study result, would have been very, very good. Another example problem, so shifting gears to a totally different type of, maybe a little more esoteric description of a problem. I'll paint you a scenario. This isn't one specific TO. I've seen this actually more than once in the last few years. So let's imagine a transmission owner is aware of all of the NERC guidelines that have come out and ESIG presentations and other recommendations coming from IEEE, and is worried about it. We're worried about high renewable penetration levels. That's a good thing. So they adopt a new technology. Maybe they pick up an EMT tool. They've got new processes to, try and address it. It's all good. But they retain some old-fashioned bad ideas. Okay, what bad ideas? Us versus them. And we are the experts. And maybe this "we are the experts" one is the most problematic when you're doing new stuff, right? This is something that we know. If you're trying it for the first time, you got to be humble. So the other attitudes are renewables are a pain. They're a problem for us. They think 100% reliability at all costs. We need to study this until there's zero chance that there's going to be a problem. And then also this blue one, rules are rules, is the one that maybe bugs me the most, because this is getting to kind of the evil of bureaucracy, right? If if you're making rules, it's true, rules are rules, but it's dangerous if you're making them up as you go. And especially in this super fast-paced environment, we need flexibility in our engineering. So what happens in these situations is developers or generator owners get stuck in a loop of trying to submit projects, but they're facing these unfriendly, inflexible attitudes, and they're rigidly held to quickly changing rules that might not be the best rules or might not make sense. So it's very demoralizing and ineffective, but also it's expensive. It means that you can't actually connect renewables, and everybody just gets more angry with each other. So another one, different type of problem. We've got modeling issues, right? So manufacturers of equipment may refuse to release accurate models. And again, this is definitely not everybody. We've got a lot of, in the previous slide as well, a lot of great TOs, a lot of great GOs, and a lot of great manufacturers. But some of them might refuse to release accurate models to protect that commercial advantage or IP. So they'll either release the minimum required and hold back key functions unless they're really pressed to do it. Sometimes we get geos involved, and who definitely are just trying to tick boxes, and they're trying to, and they'll phone in models. I'm calling it phone in, but they're trying to get across a model or across a deadline. And what can happen is that they'll submit models that are essentially randomly parameterized, right? And what that does is two things. It increases the distrust by those TOs in the previous slide, and it also potentially introduces reliability risk and study churn, right? We have to do the studies again. I got a funny one on the bottom one. It's a little bit more innocent. You could have a good PPC model, a good inverter model, but no communication model between them. And then you literally have insufficient communication, causes a problem. So those are some example problems. What are some ways that people have sort of dealt with this? And I'm calling out without permission a couple of our people we worked with in the last little while who I think are doing this well. So ATC engineers in the MISO footprint are facing huge clusters of renewable energy under the MISO process. They're essentially having to, and have had to over the last number of years, invent EMT study and interconnection processes in the complete absence of industry standards. 2800 is only released the last little while, and even that isn't maybe exactly what they need. So they just have to go ahead and invent something. Now, one of the things that they've done that I think is amazingly productive is they have weekly meetings between transmission planning and their operations group and study consultants if necessary to review the interconnection study process. So not a meeting goes by that I've been in with these things where either a planner teaches the operator something or the operator informs the planner of something, or a decision is able to be made quickly that already includes both of those two groups. And if you can get both of those two groups on the same page, you've got a pretty strong front, right? And then for interconnection projects that do have technical issues, of which there are many, they actually make this group of operations and study consultants available to the GOs to discuss issues. And if it needs to be regular as they're working through something, then it is. Now, this is more meetings, right? But these tend to be extremely productive meetings. Another example, Hawaiian Electric engineers, they're on one of the most challenging power systems in the world right now. They've got 90 to 100% renewables coming, lots of public pressure to retire those synchronous machines. Everybody wants to use more DER. They're not sure if their protection systems are going to work. They've got very high fuel costs, modeling issues. They've also got human resource constraints like everybody else. So, their approach has been sort of many-pronged, and maybe this is born of desperation, or maybe it's born of regulation, I don't know, but something in this area has happened to form a very collaborative, creative environment. So they've got a technical advisory panel that they have regular meetings with, which includes, we'll talk a little bit more about technical advisory panels. They also involve protection operation, distribution planning, transmission planning, and management in regular technical update meetings. This isn't, I don't think, every week, but it's, at milestones or at any kind of report completion. They have been very creative about procuring new technology, grid forming technology. Also make themselves available to interconnection customer teams to help with technical obstacles, and they make their technical expertise available. And then they reach out all the time to OEMs, research labs, consultants to help with technical challenges. So this is just an ongoing, maybe desperation, but definitely effective way to get out of their problems, or at least move them ahead. On the software side, some examples of collaboration that we're seeing. Definitely we have a mess in the software world right now. We have software vendors that are struggling to keep up with support for all the different types of models that are coming in, all the different, new controls that come in. OEMs themselves are struggling to keep up accurate models, not only for one software, but for many different software vendors. And for this, like I mentioned before, this fast development cycle of software. Utilities are trying to, get all of the models into their software, into their system models, and trying to adapt those custom models into their processes. And then the people who are creating generic models are also, I think, struggling to keep up with model accuracy because the equipment's changing. There's, so many different entities involved in what's required to get a generic model approved and pushed out to all the different vendors. It's just slow and clunky and difficult to make it happen, right? Happen quickly. So, that's a big problem and a lot of different problems I've mentioned there. But one of the things that's underway that I think has huge promise and that I would like everybody as much as possible to get behind and to really endorse and support is a recent collaboration between the software vendors and the model programmers to define a new standard DLL-based interface. This is a joint effort between CGRE and IEEE to try and make all of these models accurate and then sort of containerized so that different software vendors can all hook in quickly and accurately develop this. It doesn't solve all of these problems, but it's a really good step. And then we've got, some great examples of collaboration in the industry over the last few years that I think, as many of you as possible should be involved with these things. IEEE 2800, I thought, was an amazing confluence of interests and experts. It was a huge scope. And in a couple of years, it accomplished really an amazing document with lots of industry leaders across all different groups. ESIG is remains sort of their main objective is to promote this collaboration. So, they're always looking for ways to connect and educate different parts of industry. And that's one of the things that's nice about ESIG is that it's not just one perspective ever. They're, next thing you're hearing from a climate scientist or you're looking at a totally different area from your own. So that's nice. NERC continues to work really hard and I think very collaboratively over the last 5 years under the, some really good leadership there of Ryan Quint and others who have really taken the approach of, getting past problems rather than penalizing people. So NERC, I think, has overcome a lot of the stigma over the last number of, I would say, even decades that they've had, and now has some very strong efforts to improve this. And Charlie mentioned GPST as well. This is new to me in the last few months, actually, but it's not new to everybody. But it's worth looking up. Google GPST and see what they're doing because it's a pretty interesting effort to help solve these problems. Okay, so I want to give some specific recommendations for your technical groups to try and increase some of the technical interfaces between these groups. And some of this we've talked about already, but I do think every time this happens, it seems to work well. And I won't say that operations and planning groups having routine technical meetings means that they're going to be friends with each other, but it will help, right? If you actually have an idea of what the other person is doing and what their problems are. So some of the issues that could be on these agendas of these meetings is to summarize new interconnections, talk about key infrastructure assumptions. This is something that planning, always making assumptions about infrastructure. Often when you talk to an operator about those assumptions, it's not the same, right? You're not talking about the same thing. Same thing, key study results from planning or operating should be communicated to avoid disaster. Ops can talk about recent events in the operation domain that have happened because those inform the planning studies, help us focus when we're doing those studies. Looking at oscillography together, the oscillography looks different when you're looking at an operating event that's been recorded and a planning trace from a model, but it's always useful to look at the comparison of those things. And then just talk about concerns or issues or complaints you have with each other. Technical presentations is also useful. So, no recommended timing on these meetings, but they're definitely useful meetings if they're regular. You also have a hard time staying enemies if you have to talk all the time. GO and TO groups is a tricky one a little bit because it's mired a little bit in regulation. On the agenda of these technical meetings could be technical education points for the GO, just explaining why it's taking a long time, why, what specific technical problems you're encountering, giving updates on the studies that are underway. I wanted to bring this one up specifically because I'm interested in promoting avenues that allow GOs to help with technical issues. I've noticed in the industry in the last, year or so, the GOs have money a lot of the time. They're basically upskilling, whatever you want to call it. Put poaching in there, but they're hiring good people, right? They're hiring technical experts, and I expect them over the next little while to start to have a very high level of technical mastery of their own equipment, of the projects, of the interconnection things, rivaling that of the transmission owners, which hasn't been maybe historically true. And so I think this is an opportunity maybe to figure out how can we, going forward, start to tap that expertise better. Transmission and distribution is one of the funniest ones for me. The two groups, have a ton in common, but they kind of have a very clear, historically, a very clear demarcation line, right? Transmission people assume distribution, the whole distribution system is a load, right? It's just a load. We're not going to pass the high voltage bus. We're just going to call it a load. The distribution people up to the high voltage bus, they just assume that's an infinite source on the other side of the transformer. So everybody kind of keeps in their lane and does their own work and operates under those assumptions. Now, the problem is those assumptions are breaking down. They're not true anymore. And so we're having to, these two groups are having to interface. And it's interesting listening to distribution engineers and transmission planning engineers talk to each other. It's actually evolved to different languages in some ways. They have different underlying assumptions, but also sometimes different language, different software tools. So I think it would be great if we could have a bit more coordination between these two groups as they start to collide, right? We're starting to see transmission planning groups getting dragged into transmission problems. And so questions like, is voltage control required from these DERs is a very important question, and it's obvious to both groups, but the obvious answer is different from both those two groups. So why should you have voltage control? Says the distribution planner, and why shouldn't you have voltage control, says the transmission planner. Frequency response. How do we do that? Because we're going to need to. Momentary cessation. Why would you want that? And why would you not want that? Again, why would you want this thing to trip when you see a transmission, when you see a spike of overvoltage? Well, why would you not want it to trip when you see a spike of overvoltage, right? We're talking different languages, so we need to get this sorted out and have that reflected in the standards as well. Same with underfrequency load shedding approaches. This is something it's sort of merging between the two groups. Planning assumptions going forward, could be talked about. What are we going to assume? How are we going to model it? And then what would we like to change between those two groups? Advisory panels, this is something that I haven't seen a lot of, except for the example I gave of the Hawaiian Electric. I think they're great. What's happened there could be produced other places as well. If you form a technical advisory panel, especially if you're having a lot of trouble with these issues, to periodically review what you're planning to do, right? Where you're going to go with your studies, what you're going to do with your system, how you're going to operate it, what you're going to retire. And you need to bring in really outside people to this. So engineers from neighboring utilities, maybe engineers from different places in your group, protection engineers, resource planning, even regulators, third-party independent consultants. That's That's us, but you could, you know, anybody, research lab, academic representatives, those people have a ton of knowledge that tends to be, you know, they'll ask questions that you didn't even think of. And then bring in the GOs and the OEMs as well as technical experts. And one of the keys to these technical advisory panels to make them work, I think, is to be a little bit humble, right? They're going to ask questions that are going to be immediately kind of annoying to you because you know you've thought about it a long time and you think it has to be this way. But they're going to say, does it really have to be this way? Um, and that has to be sort of accepted as a question or a valid thing to think about. So this presentation, I was talking to my colleague across the hall, Garth Irwin, like what I was trying to talk about in this presentation. He says, Andrew, you can't solve this stuff. What are you doing? And he's right. I can't actually fix any of this stuff. There's barriers all over. There's all kinds of, you know, actual systemic issues that stand in the way. And I've been on the phone with an IT department or a legal department or a regulatory department. And I know that there's real issues in between all of these things. Um, so I'm going to take one last slide to sort of appeal to engineers directly and personally. Okay, so all of you guys who are engineers on the call, power systems engineers, you, what I've noticed, and I've talked to other people who have also noticed this, is that engineers, you went into engineering, you chose a profession which is generally full of pretty laid back, good people. People are trying to help, they're trying to solve problems. Um, so there's a lot of good people in our industry, right? We're not, um, you know, maybe not a lot of ultra rich people. We didn't go into finance, but good people. So what do we do? This is the hand waving, you know, Andrew preaching a sermon kind of general recommendations that just to leave you with or to think about, you know, patience, kindness, goodness, gentleness, those kind of things that, you know, we have an advantage as an engineering community and as a profession, we're already better at that stuff. Let's lean into that and sort of embrace that and reject at the same time rejecting and resisting this kind of subcultural, I'm calling it subcultural enmity. So, you know, those guys over there are so annoying. We don't have time for that, right? We got too many problems to solve. Let's not do that anymore. So another one is humility, right? This is, we know that we're missing information, especially now things are moving so fast. I'm even in my own wheelhouse, I'm missing information. So if you and I are both definitely wrong about something, then what is it? Let's figure out what we're wrong about and talk to people about it. I would like people to work to avoid transferring liability. This is really hard to do, but um, you know, to try and get to the end result, we want to not just make our problem the neighbor's problem, right? That's, it can be as some, you know, there's all kinds of ways this can happen, but you know, I think neighboring utilities in the power system, especially, we often lean on for support. I think we want to keep that in mind that that's, you know, we're working towards a common goal of this renewable transition. And if we just keep pushing the problem, we are actually going to cause a problem for ourselves eventually as well. Um, I would like knowledge sharing, and this is the, you know, people listening to an ESIG conversation are kind of preaching to the choir here, but you know, lessons learned, technical solutions, resisting hoarding of knowledge. This is something we try really hard to do in our own company to make sure you don't silo knowledge. This is something we're trying to really, you know, push back against. And it can be done, even considering IP. There's really good examples of OEMs out there who have IP in their controls. They won't share their detailed controls with you, but they'll be very forthcoming about, you know, generally how it works, and they'll want to help you understand, you know, what the issues are. And the same with consultants who have IP to protect. So you can maintain your IP at the same time as, you know, sharing what you know and being helpful. And last point, most um, vague of all, I would say just, you know, be creative and be brave because the industry is changing so quickly. we know things aren't going to be the same, so we're going to have to make some mistakes, try new stuff, invent new processes, and adapt. So I'll leave it with that. And I think that's all. I had one more slide. I was just going to, put another thing so you can type it into whether it's the chat or slide or whatever, what your collaboration success stories are or anything else that you think I've missed. And I'll turn it back over to Charlie.
Thank you, Reverend Isaacs, for that sermon. That was quite,
Thank you.
quite nice. I enjoyed it. I hope everybody else did too. So we don't have a lot of questions in the Slido yet. So now that everybody's heard what Andrew has to say and has reflected on it, please feel free to add some questions to the Slido. I'm going to start off with something that I was thinking about as you were talking, Andrew. It stimulated my thought, and that is the people pipeline. You mentioned early on that we've got a people shortage, and when people leave one place and go to another place, we don't have a net gain overall in the people department. So what do you think would work to help prime the pump? What ideas have you seen, or what ideas do you have about how we might encourage more people to go into this area? Because when you talk about the scope and the speed of the transition that's underway and all the issues that we're dealing with and all the problems that need to be solved, it sounds like we need some more people.
Yeah. I mean, like Garth Irwin said, I don't know how to solve that one exactly, but I do know that we have a bit of an image problem, right? The first thing I mentioned is just that we have all these different views of the world, and the power systems engineering view is invisible to the rest of the world. And so I think that translates right back to the universities where we have an image problem. We don't know how to get people to not be data scientists at Amazon, or we don't know how to get people to, you know, go into this field because it's a challenging field to get into as well. I don't know how to solve that one, Charlie, and I also can't really say it's wrong for people to shift around. That's a very personal thing that has a lot of implications. But yeah, I think maybe the only thing I can suggest is that we have to recognize that people are moving into different parts of the industry than maybe they have. So we have for example, the geos, we have a lot more expertise in the geo camps than we used to have. They're getting really, really smart. So maybe we need to, in some sense, relinquish some of our responsibility for these problems to the geos because they have some of the industry expertise now, so they can help. But I don't really know how to solve the overall not enough people problem.
Yeah, somehow we just need to make the industry a little more glamorous. And I think the STEM, STEM, what is that? Science, technology, engineering, and math in the lower schools, some way of in the lower grades, trying to get more kids exposed to that in a positive way that will stimulate some interest. But it's a real concern for us. It's a real concern for the industry, and I think it's something that bears a lot more thought. And along the same lines is the sort of the new people that are coming in, the generational shift that's taking place. A lot of us old guys have been around for a long time, not going to be around forever. A lot of new people coming in. And I hear a lot about the changing work attitudes, changing styles of work. Is there a generational clash? I mean, you hire a lot of young people, I think, right out of school, early in their career. Are they fitting in well? Are there changes that need to be made in the industry or in our attitudes or corporate attitudes towards younger people to get them more more slotted in, more fitted in, more comfortable in this sometimes old and stodgy industry?
Yeah, like I think that the industry, when pitched as renewable transition, it's very attractive to young people. And we've hired a lot of people straight out of university. And the reason for that is often I just can't find anybody else. or we can't find the right people around, so we'll develop people in a university. And I will say though that that's been very successful. I really, I'm proud of that in our company that we're able to develop new engineers, and I don't think people should be afraid of that. I think that that folks straight out of university can be very energetic, very productive, very creative, and they need some training, but not as much training as you might think before they're really helpful. So I think sometimes maybe the best approach if you're short of people is stop trying to hire everybody else's people and go to your local university and hire some new folks. I know it's easier said than done, but
Yeah.
it works for us.
Yeah. Oh, good. It's certainly one way of stimulating new entries into the profession. Well, it looks like we've had a big uptick in questions on the Slido, so I'm going to go to there and look at the popular ones. And
I was looking through
looks
some of those popular ones, and as soon as I see them, I'm like, oh yeah, these are my questions.
that's what I was thinking. No, I heard something,
These are
Andrew.
the ones
You
I'm
want
way
to
more
latch on
comfortable
to.
answering. Oh man, then how do you solve like not enough people in the industry? Grid forming
Yeah,
IBRs.
I thought those were good, thought-provoking ones. So the top one there is, what is the commercial readiness of grid forming IBRs? Can you provide examples?
Yeah, I'll be really quick on that one. You can buy grid forming IBRs now. A number of utilities are doing that. There's certainly some in service. Certain OEMs are offering that. I definitely think you should do that. Go out and next time you procure a battery, go build it grid forming.
Yeah. I'm going to put in a shameless plug here for the workshop that we had 2 weeks ago that you participated in, the grid forming IBR workshop in Denver. We addressed that question along with a lot of others dealing with IBRs. And those presentations are all up on the ESIG website now. And I think the recordings are available as well. So if you're really interested in digging into that area, there's some good resource material there.
Yep, a lot of good presentations on that workshop.
So do you think that the mass scale transition to IBRs is actually possible in North America at the grand scale under the price and human resource constraints? Although there's a tie into our people problem, Andrew.
Yeah, you know, I've had a lot of conversations, but this is obviously a major question for everybody, right? Nobody knows this, but I have to think we got to be hopeful about this, right? We're going to do it. We're going to connect all these renewable resources. Yeah, it's going to be possible. We're going to get there one way or another. Now, are we going to get there through our conventional process that we did 10 years ago? Probably not. That process isn't going to work. Do we have enough people to do it the way we want to do it? With our processes even restructured? I'm not sure. Can we do it as quickly as we want to? Probably not, I think. But I think we can get there, and I wonder also whether, that there needs to be, some catalysts. And I don't want to say catalyst in a bad way, but maybe it's hopefully not a blackout or something like that, but maybe some breakthroughs in software, breakthrough in data science, some new way of looking at these reliability problems. But I think we're going to get there because I think we have to.
Yeah.
I don't know if it'll be as fast as we want, but
Yeah, there's a lot of bottlenecks along the way, but a lot of work that needs to be done to relieve them and scale things up. I certainly agree with that. So the next question, how important is it and practical for planners to use user-defined dynamic models of renewable generators for grid studies?
so I would point you for that answer to that question at some of the guidance that's come out of NERC in the last little while. I do think it's important I think they'll recommend right now that you request a generic model, a user-defined model, and an EMT model. All of those three types of models have a use and an important function in the way we do our modeling. And the user-defined models, if you're going to be doing RMS type studies or phasor domain studies, there may be generators that you can't properly represent using generic models right now. So how are you going to fix that without asking for a user-defined model? Now, I know there's a lot of baggage with that question. People don't want user-defined models for a lot of good reasons historically, but I think you need to relook at that. That's my opinion.
Okay. And a question about approaches to grid studies. What are conventional and historical modeling approaches for grid studies you highlighted in the presentation, and what should be the modern approach? So what do we need to change?
Conventional and historical modeling approaches for grid studies. I'm not sure exactly which part of the presentation that's referring to. I guess I'm not sure exactly what I was thinking when I said that, or what this question is exactly driving at. But
And maybe a little more general to a question about what do these new IBR resources and all the EMT modeling that's necessary to really study them and satisfy yourself that some
sure.
changes probably need to be made.
Pertaining to EMT, that's one thing that I was referring to in the study, is that certain types of studies in the grid now are struggling with using the RMS models, but and then probably should in some sense incorporate EMT into their processes. But another sort of more systemic change that's been happening and is already happening in some places is the sequential process where we have an interconnection queue and we have a lineup of generators and we study them in order. And if one of them changes, then everything has to reconsider. I think that's been broken for a long time. And I think the new FERC, maybe someone else can tell me exactly how to get to that. The FERC changes that are being proposed towards moving towards a cluster studies and so on. Other people have been using cluster studies. I'm not an expert on that FERC process, but it's a good time to weigh in on that right now and read what they're suggesting and see what whether that will work for you and your organization.
Yeah, let's hope something good pops out the other end of the generator interconnection, NOPR.
Yeah.
A question that you will enjoy answering, I'm sure. What are the largest, most complex systems today running EMT simulations, and for what types of studies? And what about co-simulations with EMT and RMS tools?
Yeah, so that's right up our alley. But I'm gonna, anyways, deflect it a little bit and say, before I answer that question and tell you sort of how big the models are and where are they studied and what types of studies, to say that that shouldn't be necessarily your goal, right? Just because Australia is modeling all of their NEM system, all of Victoria and beyond on a single PSCAD model that looks like it runs on 3 supercomputers. That doesn't mean that that's something that works for your grid right now, and it doesn't mean it's necessarily the right thing for you to do, right? So that's one example of a big system. Hawaiian Electric is modeling all of their islands entirely in EMT as well as in our RMS tools. Other regions are using portions of the system where they don't have detailed models in the RMS domain. They'll use co-simulation to model that piece. Maybe it's a multi-terminal grid forming DC link. They can't model it in a generic model in the West, so they'll put in a co-simulation model that in EMT. So that's another use case for that. But look at what's coming out of the guidance in IEEE and in NERC. Figure out where to start. You got to start somewhere. Start looking at those critical worries that you have if you're interested in looking at EMT. You don't have to right away go out and buy supercomputers.
I think the next question is very related to that. What's the max IBR penetrations that you think you should study with electromechanical simulation before there's a need to switch to EMT? I guess it means with phasor simulation. Is there a kind of a switch over point that you run into?
So,
Very system specific.
yeah, no, I'm not going to answer that question. It's going to be
Okay.
it's a good question. It's a question everybody would like to have answered. Exactly when do I use EMT? It's a much more nuanced answer to that question.
So somewhere between 10% and 90%.
Well, Or, or it may be even one wind farm that's in a particularly unique area. You need to, haul out the EMT tool for that one because it's really weak.
Yeah.
So it's a nuanced, it needs its own presentation, I think. Sorry.
Okay. We'll have to make that the next one. Okay, and I'm going to close with this comment from Deepak. I think he was listening to you and you asked for success stories in your last slide, and so he's got one up here. OEMs, researchers, utilities, and software developers and vendors working to ensure consistent and up-to-date generic models. Thanks
Yeah.
for that, Deepak.
Thank you for that, Deepak. And I want to emphasize that what I was saying about the problems with generic models, I do think there are problems with generic models, but Deepak and his team are working hard to circumvent those. So it's definitely a good example.
Good work going on there. So we're at the top of the hour, so we're going to need to wrap it up. And I want to thank Andrew for this really thoughtful presentation. And I hope it gave everybody some food for thought. I know it did me. As I mentioned earlier, an email will go out once the video file has been posted, and we'll answer the questions we didn't get to and get them posted as quickly as possible. Appreciate your engagement and look forward to seeing you again soon. I would remind you of our fall workshop coming up in October, as well as a webinar next week on stability analysis of IBR grids, which I think most of you will find pretty interesting. Further information on all of our webinars and meetings can be found on the website at esig.energy under events and in our newsletters and informational emails, and you're all invited to attend. Andrew, thank you once again for this very timely and inspirational webinar, and thank all of you for your interest. We look forward to seeing you again in the near future. And in the meantime, everyone, take care, stay safe, and thanks for your participation. Thank you.